Hello, everyone. We'll just wait for one more minute and then we can get started. There are a few more people joining in. Okay, let's wait for 30 more seconds to get started. Okay, I think we have enough people on the live now. We'll get started. So let's bring up the session. Yeah. So today we are towards the end of the system design session. We are at day 5, where we will cover a real world system study. Before I start with today's session, I will briefly uh, summarize whatever we have covered in the previous 4 days. So, in case if any of you missed out on those sessions, you can go back and watch it. So, the first day we covered the fundamentals, where we discussed about how to approach a system design problem. So, to start with, how whenever you have a problem given at you, how do you basically get a head start? How do you gather the requirements that the problem expects you to define? So, how do you break down the requirements into a functional, non functional requirement? And once you have your requirements set, how do you go about with the next step, which is the capacity estimation? So, this is what we covered in the first day. In the second day, we covered the high level design building blocks of the system. We covered a lot of topics like databases, cache, a load balancer, CDNs. Even in databases, we covered like about database partitioning, scaling, and all of that. And whatever topics I was not able to cover during an hour long session, I listed a few topics towards the end for you to go back and read through. So that was second day. The third day was low level system design, where we covered the low level aspects of design. It primarily covered object oriented programming and few of the design patterns that you essentially run into. And we also learned about a very important principle in object oriented programming, which is a solid principle that helps you basically come up with a low level design of any problem. So that was day 3, and in day 4 we covered a few advanced topics. We learned about messaging queues, we learned about Kafka, we learned about some of the advanced topics that in any system design you might come up with those, and those are also highly used in any of the systems out there. So that was day 4, and today in day 5 we will basically combine all of what we learned in all these session in the last 4 days, and we will combine all those and see how you use that knowledge to address a system design problem. So this problem, I will be taking up a real world system, and we will start breaking down that system. We will again follow all the steps that we covered in the last 4 days, and we'll come up with a design for that system. So let's get started. And meanwhile, if you have any questions during the session, feel free to post it. I will take up the questions as I go, and if I miss those, I will take it up towards the end. Okay, now we can get started. So, the problem that I've picked up for today's session is designing a news feed. So, a news feed, what is a news feed? So, if you are using any social media platform like a Twitter, Facebook, Instagram, once you open the app or the web application, you have a feed in front of you. This feed is basically a list of stories that is generated based on the people that you follow, your friends, or the pages that you follow. So everything that they post are basically ranked based on a relevance order, and that is what is shown in your feed. So this is a very common, I would say, common feature across a lot of social media platforms. So it's a good example to learn. Also, this news feed can contain anything. It can also contain like a text, image, video, or any such. It can also contain like if there is a social media that allows you to share anything apart from a text, image, or videos, we can also scale this. We should be able to scale the solution to address those use cases as well. Apart from the content, you can also like, comment, share, and do all of those activities on a particular post. Besides this, you can also these all the feeds that are shown to you are very personalized. So the feeds that you see are only from the people that you follow or the page that you follow. So the feed is basically customized for you. So it has to be relevant for you. It's That's the primary criteria, because if it is not relevant for a particular user, if I open the app and if I see a feed that does not interest me, that particularly would make me stop using the app. So the primary criteria is to show a feed based on whatever the particular user is interested in, and that would primarily mean showing feeds from the user that they follow, their friends, or the pages that they follow, and all of that. So this is a brief about the problem statement. Before jumping into the next topic, so this is a very, I would say, a very general use case. Like if you're given a problem that you might not, in this case you might have an idea of what a newsfeed system looks like. In case you don't, you're given a question where you don't have much idea of the system. So before jumping into uh, let's say the next step, which is the requirements analysis, before that it's a good idea to have a conversation with the interviewer and ask them a brief about the system. They can maybe explain the system to you or break down the system to you in a few words. So in case you're not aware, it's also a good idea to ask the interviewer. And if you're also aware of the system, in case it's a very common system, it's also useful for you to uh, basically talk about what you understand from it. So it's good to know that sometimes it can happen like your understanding might differ from what the interviewer is expecting. So even in case you know about the system, it's always a good idea to talk through it and lay down whatever your understanding of the system is, so that both the parties are on the same page. Okay, so we'll move on to the next step, which is the first step for a system design problem. This is the starting point where we gather requirements. So, gathering requirements starts off with having a conversation with the interviewer, where you basically you can ask a lot of questions. You have to ask the right questions to get a deeper understanding of the system. So you can be asking questions like, the first question here is, what are the features of the system? So here there's an example of how the interviewer might respond is listed here. It can vary, and your design should vary accordingly. So the let's say for the important features, the interviewer can say, I want a feature where a user can publish a post and they can see their friends post on the newsfeed. So this is what the feature that the is expected from the problem. So this was a very basic question. You can also ask questions like, how do you want to sort this? Do you want to have it on a chronological order, or any particular ordering that you want in your feed? So here, a very basic ordering that we see is based on the timestamp. So whatever is the newest comes at the top. So basically, an ordering based on the timestamp might work. The next questions can also be about to get an idea of the scale of the system. So you can ask questions like, how many friends a user can have, to basically understand the number of connections that a particular user can form. So we will take a rough estimate. So, in case when you're taking the estimates of this number, you can either come up with an estimate yourself, and you can check with the interviewer and see if they are okay with the estimate. If they're okay, that's fine. If not, they can give you a number to uh, that can serve as a basis for capacity estimation. So here, what can we estimate on? So it can be like how many connections a person can have. So we have taken a rough number, 5,000 here. And what is the traffic volume? So traffic volume would be DAU, means daily active users. So we want to know how many users the platform has. At the same time, we want to know the daily active user, because there can be a lot of users that don't use the platform often. So at any when we're designing a system, we want to know what's the daily capacity of the system. The next is about what the feed can contain. So, can it contain everything: images, videos, text? So, yeah, so the interviewer might reply saying that, yeah, we want the feed to contain all of these different types. So, these are a few basic questions to ask. You might also have questions apart from this. Feel free to ask those. So, this will serve as a foundation for your next step, where you will lay out uh, after this conversation. You also have to lay out the layout. By layout, I mean you basically have to write it down. You have to break down the requirements into functional and non-functional requirements, and you have to lay down that out in front of during the interview. So, based on the previous questions that we have asked, so we'll come up with the functional and non-functional requirements. So, functional requirements can be newsfeed generation. It can be one of, again, these are like very high level. We will talk about all of those in detail. So, one feature can be newsfeed generation, where based on a particular user, we'll figure out who their friends are, whom they follow, and after getting that idea, we will create a feed for them. So, which will pick up the posts from all of their friends. So this can be one feature. The other is about the content, which again we discussed. The content can be anything. It can be images, videos, text. So that's about content. The last would be a newsfeed display. So once you open the app, you see all the feeds. Once you start scrolling, you reach towards the end, you see that your feed is again populated by a list of new posts. So basically, the feed is unending. Whenever, let's say, you refresh the app, you refresh the page, you have your feeds refreshing at the same time. So we want to understand how we want to display the news feed that we generated previously. So these are the high level functional requirements. Some of the non functional requirements can be these are the typical parameters that a system design is judged on. So the first can be scalability. We want the system to be highly scalable. We want to support an increasing number of users. So today, if we start a new system, the capacity or the number of users in the system might be low. We might start off with few hundred or thousands, and once the system is popular, it can keep growing. So our system should be able to evolve with that and support increasing user base. Then it should be fault tolerant. So if something goes wrong, let's say one of the services in the system is not working, we don't want the entire system to break down. We want to avoid that as much as possible. We want to avoid the complete breakdown of the system. So the idea here is we don't want the end users to, even if let's say we have 5 services in the system and one of those services has gone down, we don't want the end user to be affected by it and basically see any error on their end. So on our end, what we want to do is we want to take measures to avoid that scenario. So that can be achieved through redundancy, where we have uh, duplicates of those services in place, so that even if one goes down, the other, there can be like a primary and a secondary service. So once the primary goes down, the secondary can take place of the primary. Meanwhile, we are trying to fix the primary. So all of these were discussed. I think we discussed in the first day, I believe. If not first day, then second day. So if you are not aware about all these terminologies, you should go and watch the first day session. Then there's availability. We want the system to be highly available. So we also discussed about a cap theorem. I think we discussed this in day two. So cap, basically, I'm not going to talk about what it means, but on a high level, we can't, cap stands for consistency, availability, and partition tolerance. So we can't, any system out there cannot have all three at the same time. So in our case, we want the system to be highly available. So if a user opens the app, we want to see a feed. We don't want an empty page. So we want the system to be highly available. So we can compromise a bit on consistency. So compromising on consistency would mean that, let's say, if your friend made a post right now and you refreshed the your feed at the same time, it's okay if you don't see your friend's post for a few seconds. It's okay if you refresh the feed after a few seconds and that's when you see the feed. It's okay. So there's a trade-off here. So we want to have high availability, and we can compromise a bit on consistency. So that's about that. And then there is low latency. So we want the feeds to be in real time. We can have a small latency. So here we can have a few seconds of latency. Approximately, it should not exceed more than 2 seconds. So again, this is a rough estimate. You can come up with all these estimates based on your conversation during the interview. So this was the non-functional requirement. So we have completed the first step in breaking down the problem. So we have our requirements in front of us. Now, based on these requirements, the next step would be to do a capacity estimation. In capacity estimation, we will get an idea of uh, the future step when we are designing a system, how the scale of the system should look like, will be gathered based on the capacity estimation. So for the capacity estimation, we will come up with again rough numbers. You can discuss about the numbers during the interview, and you might have to shift those numbers accordingly. So let's say our system will have users. So we'll come up with what are the total users, and we'll also come up with like what are the daily active users. So for example, our system will have 1 billion users per day, and it'll also have 500 million daily active users. Now, each user has 300 friends and they follow 250 pages on average. So, you can come up with these, you don't have to use these exact numbers, you can come up with any number that you would feel makes sense. Now, based on these numbers, we have to estimate two things here. One is the traffic, and the other is the storage estimation. So, by traffic, we mean we have to estimate the number of requests that will be sent by these users. So, based on the number of requests, we will know how many requests hit our back end, and we know like the services that exist on our backend, how many requests they should be able to support at any given time. So we I think we mentioned there are 500 million daily active users, and let's say we assume that each daily active user opens the application 10 times a day. So the total number of requests that would be sent throughout the day will be 500 million times 10, which will be 5 billion requests per second, which equates to 58,000 requests per second. All these calculations are rough calculations. You don't have to use a calculator here. So even if you don't come up with 58 exact number, you can come up with 50 or 60. Any ballpark number should be good enough. So you shouldn't waste your time using a calculator here. So this was a traffic estimation. Similarly, you can come up with a storage estimation. I have not mentioned it here. So storage estimation can look something like, so what are we storing? We are storing all the metadata. So we are storing, let's say, all the data related to the user. We'll be storing user name, user ID, password, location, uh, all of those details about the user. Then we'll also be storing the details about a particular post. So post ID, the text, image, videos, all of these will be stored. So you can take an estimate. Let's say if each image is a few kbs, so you can assume one image is 100 kbs. A video can be, let's say, 1 MB or whatever, and you can assume all these limits on these particular storage, and you can come up with a final estimate. You can maybe come up with, like, if there are 500 million daily active users, so all users might not be posting daily. So let's assume 10% or 20% of the daily active user make a post. So 10% of 500 will be the number of users that make a post every day. And based on the number of posts, we can multiply that with a size of a image, a size of a video, and we'll come up with a rough number that that's the size of the database that we need to store all the text, image, videos, and all the metadata. So that's how you would come up with a storage estimation. So primarily, we just come up with a traffic and a storage estimation. If you feel a particular system you have to come up with any other estimates, feel free to do that as well. So this was all about capacity estimation. Now next step, we'll move forward. The next step will be a API design. In an API design, based on the functional requirements that we listed before, that will help you understand what features we are supporting, and based on the features that we are supporting, what are the APIs that we need. So here we need two APIs. One would be to generate a news feed. So it will take one parameter like a user ID. A user ID, when we pass that to this API, this would mean that we have to generate the feed for that particular user. So internally, it would mean that we will find all the friends that are connected with that particular user. We'll fetch all of the friends' feed. We will rank them. And once we have ranked them, we will create a feed which combines all the friends and all the ranking. And the final feed is what would be shown to the particular user. The second API would be get users feed, so get news feed. So uh, it takes two parameter, a user ID and a count. So user ID, it's pretty understandable. So based on that particular user ID, we will get the news feed for that user. uh, this news feed will be same as whatever the previous API generated. This API will just help pull those news feed and display to the user. We'll also have a count here, so it will control the limit, like a cap on the number of feed that a user is shown. So once you open the app, there might be a limit. So unless you scroll towards the end, you might just pull, let's say, 50 posts from your feed. And once the user is scrolling towards the end of the feed, that's when we pull in next 50 feeds. So a count can be an upper limit of the number of feeds we want to pull at any given point of time. So it's all of these APIs would return a JSON. So the first one would return a JSON of all the feeds, and then the next one would be pretty much the same thing. It would return a JSON containing all of the posts. So yeah, this is all about the APIs. If there are any questions, feel free to post in the comments and I can answer them. So we'll move on to the next topic. Next would be database schema. So here we have to come up with a schema design for the system. So while we are coming up with the schema design, we also have to understand the types of database that we will use for the system. So I think in day two, yeah, day two we covered. We discussed about databases in detail, where we uh, based on a particular system, we understood which database is the right to use for a particular system. It can be you essentially have to choose between a relational and a non-relational database. So, uh, which one is beneficial for your system? Which one serves the purpose of your system is what we will determine now. So here, the first you can see we have a user table where we have a primary key which is user id, and we have a lot of the metadata for user, which can be name, email, creation date, a mobile number, a last login, timestamp. Same for entity here. Entity here means a page or a group that you can follow. It's same as a user. We have an entity ID, we have a name, description, a creation date, and a creator. A creator can be another user ID. So this was for user and a page. We also have feed. Here, feed for every particular feed, we have a feed ID. We have a creator. We have content. We have entity ID, creation date, likes count, media ID. There can be other things like if you want to share a post, you can also have comments on a particular post. So you don't see all that listed right now. So based on the features that you're working with, you also have to take care of uh, those fields here as well. Like comments can be a good example. So a feed can have a lot of different comments. So you can have, I think if the relation between a feed and a comment can be one to many. So in that case, um you might need a comments table altogether where you have a comment ID and all of the data related to comment in that table, and that comment ID can be a foreign key in the feed table. Okay, the next one is media ID. So media is about again the text, images, and video. So it'll have a media ID, a description, a path, a view count, a creation date. So all of these here you can see are here depending upon the requirement. Here I think since you see there is a very linear relation between these all these different tables, you also need like a foreign key from one table that's used in another table. So for this kind of relation, it's a good idea to have a relational database. So we can be using any relational database here for storing all these tables. Now, one on the right, you can see we are storing, we also need to store the connection between the users. So, um, you as a user can have 100 different friends. So, we need to store the connection between a user one to all these 100 friends. So, this, as you would know, the best idea to store these kind of structure would be a graph database. So graph, you can easily able to store the relation between all these friends, and you're also easily able to find like the mutual friends and all of that. So a graph database makes more sense here. So a graph will be stored, you know how graph can be stored in the form of adjacency list or a table. So that's what we're using right now. So one on the right here, you can see we have relation ID, and then we have relation from and relation towards. So this is a user ID, and then there's another user ID. So here, if we are storing for let's say list of all my friends, so I'll have my user ID here and all of the other friends user ID in the this row, and we'll have many rows in the table depending on number of friends I have. So this is how we store the relation. So this is a gist of what the database would look like. We'll move on to the next. So before moving on to the next topic, at the same time, it's also while you're defining the database, it's also a good idea to talk about the database scaling. So, as your database is scaling, let's say I spoke about that we will use a relational database. Now, relational database, uh, we covered in second day session that there are two types of scaling. There is a horizontal and there is a vertical scaling. In vertical scaling, we can scale a particular database up to a certain limit. You basically add more resources to the system, and then depending upon the number of resources you keep adding, the database can increase its capacity, but there is only a certain limit that you can increase the database up to. So if we still want to scale it further, we would be using horizontal scaling, where horizontal, you would understand from the term horizontal means we go sideways. So we keep adding more database to the system. So if one database is not sufficient to, let's say our first table is the user table. If one database is not sufficient to store all data, all the user metadata, we will add a second database. If all two are full, we'll add a third one. So on. We'll just keep expanding. So this is called horizontal scaling. So while you're talking about all this, you can also talk about, we covered this topic previously where we discussed about sharding. So once you have multiple database storing the user table, how do you want to, uh, how at any given point of time, how would I know that which, let's say if I have 5 tables storing the user data, how would I know if I'm looking for my data, how would I know which table is storing my data? So that is where we should come up with sharding logic, where sharding means to find out, here in this case means how we want to partition the data. So let's say we can use a very basic idea would be sharding based on a user ID. So we will have a hash function. So hash function will basically take the user ID, and the value would be a ID of the database that the particular user resides in. So I'll give my user ID and it will give me a ID of the database that my data resides in. So this is a very basic example of sharding. There can be again multiple types of sharding. So once you're laying out the database, it's also a good idea to talk about the scale and sharding of the database. Okay, so this all about database. Let's move on to next topic. So next will be when we have, so what we have already done by now is we did the requirements gathering, we did the capacity estimation, we did the API design, and we did the database design. So after we are done with all these, we can come up with, we have good enough idea to come up with a high level design. So this is what a high level design should look like. Again, there can be a lot of variations to the design. So in a system design interview, there is no right answer, there is no single right answer, there can be multiple variations of the design. So until you are able to explain your approach and provide a reasoning behind the design, it's good enough, even if your design is something which is totally different from this design. So, and also you don't have to come up with this fancy blocks. You can just, it can be as simple as just writing down the names and just joining all these pieces by arrows. So we have client on the left, we have a load balancer. We need a load balancer to scale the system. If you don't know about load balancer, you should go and watch. I think I did it in day 2 or day 3. Yeah, I think we covered it in day 2. So you should go and learn about what are the different types of load balancer. Then we have a web server, which basically that's where our request from the clients go through. This is the starting point of the backend. And then we have multiple services. So you should be able to connect this from the requirements that we laid out previously. So we laid out that there will be a service that will generate the feed. So we have a notification generation service, we have a publishing service where we publish the user, we have a post service. So when somebody posts a feed, this service will take care of that post, and it will go. We also have like a post cache and a post database. So once a new feed comes in, the service will store it into the database and also store it in a cache. And while storing in the cache, it will take care of all those cache policies and everything. uh, Now we also have a blob storage here. So blob is a binary large object storage. So blob storage is ideal for storing all this media related content. So images and videos would be stored in blob storage. Uh, Primarily, it is we use make use of cloud storage for this, which are extremely cost effective. So, and then we also have a newsfeed cache. So once the newsfeed is generated, we will store all of that in this cache. So this is the high level design of the system. We have client, server, and all the services breakdown. So you can see these services are still on a very high level. So we have just said that we want a newsfeed generation service, we want a publishing service, but we haven't here explained much that goes behind it, because obviously like each of these service in itself are pretty huge. So here in a coming up with a high level, it's okay to break down the problem how we did previously, how we came up with the functional requirements. So same thing, you can have like each service take care of one requirement, and you can have databases or whatever storage that the service needs to interact with, you can have that accordingly. So this is the high level. Now the next step would be to dive deeper into these services. So now is a good, so after you have laid down the high level design, you can get a feedback from the interviewer and see if they are happy with the design, or if they feel that you are missing a few pieces, they will help you identify that. And once you are done with a design that the interviewer is happy with, the next step would be to find out a particular or maybe a few of the services that you want to dive deeper into. It can be services that you can pick on your own and see that which services can be interesting to talk about. At the same time, interviewer might also want you to focus on particular services. So if the interviewer wants you to focus on any of the services, you should be diving deeper on only those particular services. Because sorry, because in a 45-minute or an hour long interview, you don't have time to go through all the services. So make sure you understand which of the services you want to dive deeper next. So here we'll dive deeper into two services. Let me go back to the slide. Yeah, we are diving deeper into the generation service and the publishing service. So these two are very interesting, and rest, I think post service can be a subset of other services, and it can also be very straightforward where once you have a post coming in, you are just persisting that post. So there's not much to talk about here. So you can understand how you should cleverly choose the next point, next service that you want to dive deeper. Okay, so we'll start with a generation service. I will take about, let's say, 5 minutes to explain this service, and we'll take another 5 minutes to explain the other one, and then we'll wrap this up. So, the newsfeed generation service. So, how are we generating a newsfeed? So, for any particular user ID, we go and find out all the friends that the particular user has. So, we can run a query on the database. So we are already storing all the user and their friends. So we can go and run this query where we, from the user table, we go and collect all the friends where the user ID is the current user ID. And so there is one query for the user, and the second one is for the entity, which is the page or a group that the user follows. And we have to combine those, so there's a union here. And we are also ordering, so we want to rank the feed based on the timestamp, so we are also ordering them based on the creation date. So you can understand that if we are doing this every time a user opens the app, every time a user wants to see a feed, it can slow down the system. Because at any given point of time, we discussed that we want to have about 500 million daily active users. So imagine if at any given point of time there are millions of users that are active, and for every such user you run a heavy query like this, it will just slow down the system. So, and it'll also give a poor user experience where you open the app, but you see that there is a latency there. It takes a few seconds to come up with the feed. So, it will provide a poor experience to the user as well. And we don't want that to happen. So, what solution here can be something like we want to have an offline generation of newsfeed. So whenever the user opens the app, we don't want to run all this query every time they want to see a feed. We can do it offline. We can have, based on the requirements, we can have a cadence where, let's say, we do this once every hour or once every 5 hours, depending upon the scale. Uh, we calculate the feed offline. We store all these feed in a database, and once I come online, I the service will just query from the database and show up the feed. So it will save all the calculation of basically finding all my friends, getting their feed. Once you have got everyone's feed, you also have to rank them. So saving time from all of these, it will just reach out to a database and collect all the feeds from there. So this will save a lot of time and provide a way better experience for our end user. So once we're doing an offline generation, so you can see this is the design for generation service. So here it's pretty much same. There's a client, there's a load balancer, there is a web server, and we have a newsfeed generation service. Now here we have a graph is where we are storing the user and a follow data. So all the connections between the user and their friends are stored here. Then we have a user cache which stores all the user metadata, and there is a post cache which stores all the post related data, and all of these caches have their own databases. So what these service does is it goes through all these different. So first it goes through the graph database, and it will so you remember how we defined the API. So we defined the first API, which is the generation API. So once, let's say, the API hits the service for that particular user ID, it first goes to the graph database. It collects all the friends. Then it goes to the second database, where for all those friends, it collects all the metadata for that user it needs. Because here, for that particular user, we will get the post ID for that particular user, which will tell the post that that particular user has made. And once we have all those post ID, we can go to the post cache and we will collect all those posts. So once we have all the posts from my friends, and then all of these are fed into a ranking service. This ranking service, you don't have to dive deeper, but you can talk about what this ranking service should do. So what it will do is it will take all the posts from my friends, and it will come up with a ranking of all the posts. So the ranking can be based on a lot of machine learning algorithms. It can have basically a score attached to all the feeds. So there might be a friend that I interact with frequently and I like to watch their post than compared to someone whom I interact lesser than this friend. So the first friend will be a higher score than the second friend. So all of these ranking is done here, where all the posts are assigned a relevant score. Based on the score, we will know that which feed we want to show on the top. So once we have done all those calculations, we will store everything in this cache. So this cache is what stores the newsfeed cache. So we also have CDNs here. CDNs is content delivery network. We learned about this during day 2 and bit in day 4 as well. So go back and watch that if you haven't already. And CDNs help basically, uh, these are nothing but like local servers. So if a particular application is used by entire world, so if someone is in India and their feed is, if let's say the database is stored somewhere all around the world in US, the there will be a huge latency. So we want to store all the data related to a user in India closer to India, and somebody who's in US, we want the data to be stored closer to them. That's what CDN does. So once the feed is calculated, we will store everything closer to the user. So that's where we'll make use of CDNs. So this is what a newsfeed generation service would look like. Uh, this would be again, I wouldn't say it would be extremely detailed, but depending upon the feedback that you're receiving, you might the interviewer might want to you to explain few pieces here and there. So depending upon that, you should be explaining those pieces. So this should be good enough for our newsfeed generation service. The next we will come up with a publishing service. So publishing service, what it does is it takes everything from the cache that we have already generated. So from that cache, it will show the feed to the user. So showing the feed is, it's pretty interesting. There can be multiple approaches that you want to take care when you want to show a feed. So there are a few different models that we can follow. So the first, you can see on the left hand side, we have three different types of options. So we have a pull model, we have a push model, there is a hybrid model. So I'll explain what all these means. So pull model, from the name you can mean we are pulling the data. So what it means is, let's say I have opened my feed. I'm seeing the the feed generated from um, the feed generation service. Now, at the same time, while I'm on my feed, it can happen one of my friends makes a post. So every time, for all of my friends, whenever they're making a post, the service should be pulling the data from the because whenever there is a new post made by my friends, the generation service will come up with new list of posts for me. So once I am accessing a post, should the pull model would mean that the service would pull all the data from the newsfeed generation, sorry, the newsfeed cache. Here, what there's one drawback, which means is, let's say if we come up with a logic that we want to pull the data every minute or every maybe 30 seconds or so, there can be a chance that every 30 seconds there is no new update in my feed. Maybe none of the friends have made a post, or none of the pages that I follow has made a new post. So in that case, what happens is the request that I sent every 30 seconds is going to return an empty result. So it causes a lot of overhead because you're just sending every request has an overhead. There is a cost associated with that. So you're making a call but you're not receiving anything. So this won't be a good idea because you're just exhausting your resources. So that's where the next option comes, which is a push model. It means that whenever there is a news feed available, rather than the client pulling it, we have the service pushing those feed to the client. So the feed will know when there is a uh, the feeding service will know when there is a new feed generated, and whenever there is a new feed, it can just push those feeds to the client. So compared to the pull model here, uh, we won't exhaust the resources where we are just getting empty responses. So here it seems a good idea compared to a pull model, but there can be other drawbacks here as well, where let's say if there is a popular user, let's say if there is a movie actor, and there are a lot of people that follow them, so there can be millions of people that follow them. So uh, in that case, if you want to if you want to use the push model, we'll have to push it to all those 1 million. Let's say if there is 1 million user, you have to push to all the 1 million users. So again, this will also cause a huge overhead. It can happen that out of the 1 million people that follow them, not all of the users are active. Maybe 50% are don't even open their apps daily. So in that case, why do we want to push it? So whenever the actor makes a post, why do we want to push it to all the 1 million or I mean millions of users that they follow? So that's where we come up with the last approach, which is a hybrid approach, which basically means we combine a pull and a push model. So we take the best out of all these two models. So the example that I gave for somebody who is really popular, in that case, uh, we'll set up a limit. So if there are a lot of users that follow a particular user, in that case, we can opt for a pull model, and in rest of the other cases, we will go for a push model. So this is what these three types look like. Um, what I covered is again very, I would say, briefly explaining about all these models. You should also go back and learn more about what these three models mean. So this was about the publishing, and we can see that it is similar to the generation service. You have client, load balancer, web server. There is a news feed publishing service here. It has access to a newsfeed cache. So this is the cache which was generated previously in our last step, which is the generation service. So the publishing service directly interacts with the cache. Now you can see we also have the publishing service interacting with the database. So why is this happening? So let's say in a newsfeed cache, once the feed is generated, we if for every feed generation we go and store everything in the cache, let's say we store all the metadata plus the media, so we store all the images, videos, everything in the cache again, it will just blow up because the metadata contains requires huge resources. So what we can do is we just store the identifier for those. So once we are generating a news feed, we can store just the let's say media ID. So rather than storing the video, we'll just store the video ID in the news feed. So even that is pretty provides a reasonable uh, approach to save on the storage. So once you have that, the publishing service can, once you have, let's say, the media ID, the publishing service can go to the blob storage and then they can fetch the media from here. Same for like a post. If they want to fetch the post, they can do the same thing, collect the post ID and fetch it from the post database. Uh, yeah, so this is similar to the generation service. And I think this should be enough. Yeah. So again, if the interviewer wants you to talk through more about any of these particular components, you should be able to do that. And here you should keep a note of all these three different types of options. So it's very important to talk about the trade-offs, how I explained why, what is a pull model and what are the cons of the pull model, and then why we use a push model, what are the cons of a push model, and why should we go for a hybrid model. So all of these you should be able to explain. Yeah, so this is all about publishing service. This, I think this is the last slide. Yeah, so this was the last slide where I we drove deeper into two of the services, generation and publishing service. So this gives, the whole idea of this session was to give you an idea of how interview should look like. So we started off with requirements. We did a capacity estimation. We did database schema design. We did a API design. Once that was done, we came up with a high level design. After coming up with a high level design, we further dive deeper into few of those components from few of the services from the high level design. We went deeper into two of the services, generation and publishing service. So I think this is what an end to end gives you an idea of what all you should cover, and depending upon the feedback that you are receiving in an interview, you should be able to dive deeper into those topics. Yeah, so I will wrap this up now. At towards the end, I want to open it for Q&A. So if you have any questions, feel free to post. You can also connect. You can scan the barcode on the right. You can also connect with me on LinkedIn if you have any questions. Yeah, I don't see any questions as of now. If you have any questions, I'll wait for a few more minutes before wrapping up. And we also towards, so this was the last session. So I hope if somebody who attended all the five sessions, they should have a good understanding, and I hope they got to learn a lot. If you have missed out on any of those sessions, feel free to go back. The recordings are available on YouTube. You should go back and watch those. I can confirm that it's going to be really helpful when you're preparing for a system design interview. Okay, I don't see any more questions. I think I will wrap this up now. Thank you everyone for joining. I hope this was helpful, and keep in mind, if you have missed on any of those sessions, you should, everything is available. You should go and watch those, and it should be really helpful for you. Thank you. Bye.